Hey builders and makers, I'm back again in the workshop. I'm having fun building these little Cessna gauges. This one is an RPM gauge out of probably a Cessna 172 based on the RPM limit. I found this on Thingiverse. It uses one servo. It has the same coupling as for the turn coordinator, so the servo just kind of mounts into there without any trouble. This is just a standard micro servo. It is gear reduced, so we have a big gear driving a small gear so that we get more than 180 degrees of rotation. So we can... I've also come up with, just for fun, I called it the Servo Cal 3000. All it is it's a nano clone that I had around. It's a rotary encoder. It's a little display that was around. And then I've put a jack here so that I can plug in my servo and control it. The display is the value that the Arduino is sending to the device, to the servo. And that ranges on an Arduino from 0 to 180. So I have it set at the middle here so that we can calibrate our servo so that it's in the middle of the scale. You can see when I change this, it changes the position. So we can both test it and also determine what range of motion we need. So at 90 we should be about in the middle of the scale, and then when we go, then we can just record. You can see 0 is at 32 on the scale, so I'm going to write that down. And let's find the top of our scale. That's 3,500, and that equates to 145. So when we set our scaling, Xplane should be sending us a number between 0 and 3,500 for this, and we just scale that to 0 to 32 and 145, and we should be good to go. I'll write up the plans for this little device here. I also have it set up to send the value to the serial monitor so that you don't have to hook up the display or buy one if you don't want to. So then it would just be an Arduino, a rotary encoder, and then hook it up to your servo and you're good to go. I'll make this code available on the Patreon page. Now that we have our numbers written down that we need, we can disconnect the calibrator. So this print was based on Thingiverse item 24893222. I'll put a link in the description for that. It comes with backgrounds that you can print for vertical speed, RPM, also airspeed. So I'll probably be building all of these. There's plenty of options for gearing, different size gears, different types of needles that you can print. Those little parts are a little bit tricky to print, so make sure your printer, if you're 3D printing this, make sure that your printer is tuned up pretty well. I had to calibrate mine a little bit. I'm going to base this build on the previous one that we did, the XPLPro turn coordinator. Eventually these will all be combined so that you can hook all of your instruments to one device, but I'm separating them so just for the purpose of demonstration so you can see how I'm doing it. So I'm going to save this one as XPLPro Cessna RPM. I'll make this print a little bit bigger for you. Alright, now we can see what we're doing. So we'll call this one XPLPro Cessna RPM. We're going to maintain this using the servo library. XPLPro is here, so now we have to define a servo for RPM. We don't need this one. I'll put this one on pin 6, I believe I can use. For the time being, remember that you have to use pins that are capable of putting out pulse width signals for your servos. I do plan to use a servo multiplexer pretty soon in this build. We need a data ref to hold our RPM. This one's going to return a float, and it'll be in a float array, but we'll talk about that in a minute. This is just the name that is sent to Xplane. I released my plugin. Let's go down to the register first. So we got DRF RPM. Let's go find that one. On the Xplane site, you can search for RPM. This looks like the one that we want. We're going to use that, and we'll see. We don't need this one for now. We want to request updates. I'm okay with a resolution of 10 RPM, so let's create a precision of 10 RPM. We're not interested in 800 RPM versus 801, so 810, 820, that kind of thing. I'll make this 100 milliseconds just to smooth it out a little bit. It's also, I think this is an array, so I'm going to request element 0. Even if it's not an array, element 0 is still the same thing, so it should work. Set scaling. I'm just going to take a guess here that Xplane is going to give us a number between 0 and 3,500 for our RPM, and our numbers that we calculated earlier were 32 and 145. So we'll get that scaled. On the inbound handler, all we have to do is watch for the RPM data ref to come through and write it out to the servo. That should be a done deal. Let's plug it in. Now we just need to wire up our servo. It needs 3 connections. The first one is ground. The next one is power. And whatever pin you chose. I chose pin 6, which I think is a PWM pin that should work. And alright, we are connected. Alright, looks like we're up and running. We'll launch Xplane and we'll see what happens. Alright, Xplane is up and running. Let's load the Cessna because that's more appropriate for this gauge. There it is. So I did download the latest beta version of Xplane 12. I think there's one more update that I haven't installed yet. This is looking pretty good with a little bit of minor tweaking. I think we can adjust the RPMs to match just a little bit closer. But there you go, nice easy build, nice easy programming. I'll probably build out the rest of the VSI and the airspeed indicator. Since they are essentially the same build, I'll probably, in the next one, I'll multiplex these all together so you can see how that works. Downloads of these examples are available at the Patreon page. I'll also include this example into the example folder of the XPLPro library. Next time I send an update, it should be in there for you. The wiring diagram I'm probably not going to do for this since it's so simple. If you have any questions, please ask in the comments section, or better yet, find us on the Discord page. I'll see you in the next video. Thank you for watching.